Welcome back, and in this video we're going to be talking about vertical and horizontal asymptote. For the problem number 31 over here, we want to find out if there are any vertical and horizontal asymptotes from the graph. So I call vertical asymptotes VA and horizontal asymptotes HA because it's just convenient to write it down and to pronounce. So A. First of all, they ask us to find X-intercepts and Y-intercepts, basically preparing us for the idea of asymptotes or just in general to know the behavior of the function. So remember how to do that. For X-intercepts, you always look where your y or f of x is 0. For Y-intercepts, it's the other way around. You always look where the x is 0. So if you want to find X-intercepts, you look where the height, which you remember up and down, right, is 0. When you look for the Y-intercepts, you look where your run, remember, so rise, and in this case run is 0, and run 0 basically means when it is x is 0. So you just plug 0. That's actually a simple one, I would say. So for X-intercepts, we're looking where y is 0, and y is 0 means the height is 0, and I see it's over. So here's the height of my function. Here's the function, and it's keep decreasing like this and going to the right. Or there's also a piece over here. So a piece on the left never even approached pretty close. X equals, never even approached really close, y equals 0. And it's exactly what we're looking right now for X-intercepts. We want to know where the height of the function is 0. So imagine this is the floor. So x is my floor, let's say. And we want to know where the height is 0. Well, do you see? It's over here. Literally, it intercepts y equals 0. So that's why you call it X-intercept. Make sense? Because it intercepts y equals 0, which is the same thing as to say x-axis. X-axis. But where does it happen? If you zoom in, actually you can see it is -1. So I'm choosing this answer over here. For Y-intercepts, I'm just plug x equals 0 and see what's gonna happen. To plug x equals 0, I'm gonna just look here at where my x is 0, right? So here it is. It's literally an interception of the graph of the function and where x is 0. So this happens at -2. -2. That's why I'm gonna put it here at height -2. Now we want to look for the vertical asymptotes and horizontal asymptotes. So vertical and horizontal asymptotes are usually shown using dashes like this. Vertical asymptote is the wall which you cannot cross, which the graph of the function cannot cross, VA. That's why there is even a joke that there's a Gandalf standing like this. Here's his hat, and then he holds a wand or a stick like this, right? And then guess what he says? He says, you shall not pass. You shall not pass. Because vertical asymptote should not be passed ever at all. Unlike horizontal asymptote, by the way. You shall not pass. So that's a famous joke. You can Google it about vertical asymptote. So you need to write down the equation of this asymptote. Since this asymptote is going through like this x-axis and it's a vertical line has equation x equals blah blah blah. Because how would you define it? All vertical lines have some kind of equation. This one is x equals 8, right? How to the right the line is. This one is x equals 6, for example. Those are random lines I just figured out on the floor. So what is the equation for the vertical asymptote on the left? What where to the left or to the right it is from the 0? Well, it is -2 to the on the x-axis, so it's basically over here, -2. The equation will be x equals -2. Make sense? You basically write down the equation of the line. Since it's a vertical line, the equation of a vertical line is the location on the x-axis. And the other way around will be for the horizontal asymptote, which I like to denote HA. Horizontal asymptote crosses y-axis. That's why if you want to write down the equation of the horizontal asymptote, you need to locate how high or low this line is. It's horizontal. So the equation for that one will be y equals, because y indicates height. Well, it seems like it's -4. So the equation for the horizontal asymptote will be y equals -4. So remember, vertical crosses x-axis. That's why the equation is x equals something. Horizontal crosses y-axis because horizontal. That's why the equation is y equals something. Both are lines, and that's why these equations are lines. Find the domain and the range of the function. Well, as I already told you, the graph of the function cannot cross that vertical asymptote, shall not pass it at all. So that's the important thing to consider, and just trying for you to understand how to figure out the domain of the function using the graph. So say I will just, erase everything because it's a little bit too much over here, and then I will show you this way. The only thing I need right now is this blue color of the graph of the function. Here it is in blue. Put literally your pencil on it and see how far you can go from the left to right, and if you had to take your pencil out from the paper. So here it is, I'm going and I'm going and I'm going and I'm going and I'm going down, and then I had to take the pencil out to keep going from over here. So the moment I had to take the pencil out, that's the moment I should indicate in my domain as the bad moment. So this is a moment of discontinuity, where the function is not continuous, or basically there's some kind of gap happening. This gap is happening at x equals -2, where the vertical asymptote is. Why it's happening? Because the vertical asymptote shall not be passed. So the domain in this case is everything from -infinity. Remember how my pencil was going from -infinity. Then it's kind of stuck very, very close to -2. So I'll write down to -2. Then I will never reach -2. So we'll write down parentheses in the union, and then from -2 to +infinity. Now, how about range? Can we figure out range? Range, now instead of looking left and right how my pencil is going, I will be looking up and down. So range looks like this. Seems like everything is fine from below up to this horizontal asymptote, right? And the equation for this horizontal asymptote is y equals -4. So I'll write down from -infinity to -4, not touching -4, union, and then from -4 and up to +infinity, to infinity and beyond, where actually is the other way around, beyond and to +infinity. So up means over here. So that's the idea. Range happens vertically, and then domain happens horizontally, left and right. Now, what if we don't have a graph of the function? Then we are asked to think carefully. And this is where you need to know how to compare linear function over linear function when you are asked to figure out vertical and horizontal asymptotes, VA and HA. So VA is actually a simple one. Just look at the denominator and solve it for 0. Find zeros in the denominator, the bad guys, the bad points. X, so -3x, in this case will be 9, and x will be -3. So -3, in this case, that's equation x equals -3. That's going to be equation for the vertical asymptote. And it comes from the denominator of the fraction. So I can put it there right away. I'll put -3. And remember, people agreed to put dashed line. So you should do that too, to match the international notation. That means even if you go to Japan and show this graph, they will know that this is VA vertical asymptote with the equation x equals -3. And everyone knows that you cannot pass it, even if they don't know the joke about the Gandalf. Now, how to find B, horizontal asymptotes? These are a little bit trickier. Let's assume that you see in front of you here -7 at the top, and that's a polynomial, and -3x minus 9 at the bottom in the denominator. That's a polynomial as well. The power or the order of the polynomial in the numerator, let's call it n, and the one in the denominator, let's call it m. So we actually try to teach you to recognize that if n less than m, then horizontal asymptote is y equals 0. If n greater than m, then there is no horizontal asymptotes. That's pretty simple. And finally, if they have the same order, the polynomial at the top of the fraction, the polynomial at the bottom fraction has the same order, then you look at the ratio of the leading coefficients. Ratio of the leading coefficients, that is, the coefficient of, I'm actually gonna write down, ratio of the leading coefficients, and you'll see it right now. So I would say, sometimes people say leading constant in the numerator over leading constant of the denominator. So in our case, let's see, n and m. In this case, it seems like the order of the polynomial at the top is -7. What kind of order is that? Well, you just need to imagine x to the 0 over here. Then the order of the top is 0, because x to the 0 is 1. That's how you should see it. At the bottom, we have x, and it means the order of the polynomial in the denominator is 1. So which case do we have here? We have the first case. The first case is n less than m. So I can write this down, n less than m. That means I have a horizontal asymptote, and its equation is y equals 0. And I'm going to put it in a dashed line over here. Y equals 0, here it is. Y equals 0 is my horizontal asymptote. Let's do one example, which is more interesting in this case, but remember the same rules. So, first you need to find vertical asymptotes. Those are pretty straightforward. I just take the denominator, and I want to find those bad guys, where the zeros happen. Well, in this case, do I have two solutions or one? If x squared equals 4, then the solution is 2, right? Well, not always. 2 and -2. Don't forget, -2 squared is 4 as well. So we have actually two vertical asymptotes. Let's put them on the graph. One is located at -2. Vertical asymptote is vertical, don't forget. And the other one is located at 2. Here it is. Vertical asymptote has equation here, x equals -2. And over here, x equals 2. Very good. Now we're looking for horizontal asymptote. And again, what is the order of the polynomial in the numerator? I see square, so n is 2. In the denominator, it's square as well. So m is 2. Then it means it's a second case. 1, 2, 3. Second case when n equals m. And it's the interesting one. Oh, third case. I actually named it to be third one. Okay. So it's the third case when n equals m. That means you need to look at the ratio of the leading coefficients. -2 all over what is the leading coefficient in front of the x squared at the denominator. Oh, that's actually 1. So the answer will be 2. Horizontal asymptote is, in this case, is going to be y equals the ratio of the leading coefficients -2 all over 1, which is -2. Does that make sense? Basically, you find the leading term of the polynomial at the top and the leading term, the polynomial of the bottom, if they have the same powers. That means they kind of cancel out each other. x squared over s squared, and that's why the answer will be the ratio of the leading coefficients, which is -2, over 1, which is -2. Let's draw it over here. Here's my -2, and here is the dashed line. That's going to be HA with the equation x equals or y equals. We'll think about that. It's height, right? Height. Height is described in terms of y, so that's -2. And that's all. This is how you graph and also find horizontal and vertical asymptotes from the given function. Hopefully that made it a little bit easier to understand. Write down those 3 cases, and intuitively they actually make sense that if m equals n, you find the ratio. But if the top of the fraction loses to the bottom, then the answer is 0. If the top wins, that's the second case over here, then there is no horizontal asymptote. In Calculus 1 class, we're going to explain you more why this is happening using limits. Good job for watching, and see you next time.